Hello everyone, welcome to our channel Code with Sunny, and in this video I am going to talk about the fourth problem of educational code forces round 108 rated for division 2, and the problem name is maximum sum of products. Okay, so let's try to first discuss this problem statement and we will together find it out the best solution of this problem. Okay, so we have been given two integer arrays a and b, both of length n, and we can reverse at most one subarray, and the subarray is basically a continuous subsegment of the array A. Okay, note that we are going to reverse at most one subarray, that either we are going to do nothing or reverse any one subarray of the array A. Okay, note that it is array A only, not the array B, and our task is to reverse such a subarray such that this sum is going to be maximized. Okay, now what is my current sum? You can see current sum is ai into bi, and we have that is we have to sum up for all the I the value of ai into bi, and if after reversing one subarray, can this sum is going to be maximized or not, and what is that suitable subarray, and what would be my new sum, new maximum sum? We need to figure it out that. Okay, so let's look over the constraints. N is going to vary up to 5000, and the integers are like a1 and it goes up to an, and every value is around 10 power 7, and similarly bi is also up to 10 power 7, and we need to print the maximum possible sum. Note that we are only going to print this sum, okay, after reversing at most one subarray. Okay, so let's try to discuss this problem with the help of example and find out the best approach for this problem. Okay. Okay, so here I have taken one example. You can see this is the array A and this is the array B, and we need to reverse at most one subarray of this array A so that our sum, and what is my sum, is going to be maximized. Sum is like AI into BI, and for every I starting from 1 and it goes up to n. Okay, and okay, let us find out what is my current sum. My current sum would be like 2 into 1 plus 3 into 3, and plus it should be like 2 into 2, and it again you can see 1 into 4 plus finally 3 into 2. Okay, so there basically I'm just I'm basically summing up all the values of this one, that is make the product of these two integers, and find out the sum and just sum up this one, this one, this one, this one, this one. Okay, I'm just basically trying to find it out. Okay, so let us first find out what is this sum actually. 2 plus 9, and you can see 4, and it is like 4 again, and 6, and you can easily see summing coming out to be 11 plus 4 15, and it is like 10 25. Okay, so this is my current sum, and we can either reverse any one subarray, or we are not going to do anything. If you are not going to just do anything, this is my sum. Okay, now if we want to just perform one operation, that is reverse any subarray, can this sum is going to be maximized, or it means that can we get some sum equal to greater than this 25 value? So let us try to find out if we can get the sum greater than this 25 value. Okay, let us try to just reverse this subarray, that is choose the subarray starting with index equal to 4 and it goes up to index equal to 5, and reverse this subarray, that is this one. Okay, so if we try to reverse this subarray, what is my new array formed? My new array formed would be like 2 3 2, and it should be like 3 and then 1. Okay, now if we try to find out the product, that is ai into bi, and sum of all the values for every I, you can easily see my this sum remains same, this one remains same, this one also remains same, and these two will differ. And how by how much it will differ, let us try to find it out. It will differ by, that is my new sum would be like 3 into 4, and plus it should be like 1 into 2. Okay, so you can easily see sum is coming out to be like at this one like 15, plus my this extra sum would be like 12 plus 2. It should be like, I think 12 plus 2 is like 27. Yes, I think it is going to be correct. Yes, 4 3 12 and 2 1 2. It should be like 12 plus 2 14. Okay, so it is coming out to be 14. Yes, I think yes, it is 14. So you can easily see I am getting the sum as 29, and which is obviously greater than this 25. Okay, you can easily see my maximum sum will come out to be this 29, and we should report that this is going to be our maximum answer. just I have just find it out. If I can reverse this subarray starting from this 4 and to this 5, and then we are going to find out the sum. It is going to be like maximum 1. Okay, 29. Okay, now the main approach is going to be like how we are going to find the suitable subarray. Okay, you can easily see we can find this suitable subarray in O of n cube time complexity, and let us try to first understand this O of n cube time complexity, and they will try to optimize that time complexity to this O of n squared solution to find out the best one for this problem. Okay, so let's try to understand. Okay, now let's try to figure it out first O of n cube solution, and we will try to optimize it further to O of n square solution. Okay, for every I starting from this let's say 1, and it goes up to this n, and for every j starting from I plus 1, and it goes up to like last one, that is n. You can see I have a subarray starting from this index I, and it goes up to this index j, and we are trying to just reverse this subarray, and we are trying to find out this sum sigma ai into bi for every I starting from this 1 to this n. You can easily see this outer loop runs around n times, and this inner loop also runs around n times, and for reversing this subarray and just again finding out this sum, it would take off like time, it would take iterations around n, and overall we have O of n cube time complexity. Okay, so can we this just reduce this time complexity to O of n square? Yes, we can easily reduce that. Okay, you can easily see this loop runs around n times, and this one also runs around n times. And can we just answer that after reversing a subarray starting from this I, and it goes up to j in O of 1 of in O of 1 time or not? Yes, we can easily answer this in O of 1 time by just some pre-calculation. Okay, so let's try to focus how we are just going to pre-calculate. That is, if I'm going to try, if I'm trying to just reverse this subarray starting from I and going up to this j, and can we just reverse this subarray, and can we just find out this sum in O of 1 operation or not? And what is that sum? That sum is going to be like sigma ai into bi starting from this I, and it goes up to I equals to 1, and it goes up to n. Can we just find out this sum after for the subarray I comma j in O of 1 operation or not for every I comma j, because this is already like time, this has already like O of n square time complexity, and we just need to focus on how we are going to just answer for every subarray. What should be the answer for this one in O of 1 time? Okay, so let's try to find it out how we are going to do that. Okay, so I'm just trying to just write 3 4 methods, or method you can say, the subparts of this problem, and how I'm going to do that. Let's try to first figure it out. Okay, so my first approach would be like I'm going to write maintain a prefix array, let's call it as a prefix array of like ai into bi. Okay, and my second approach, my second sub part would be like maintain a suffix array also, suffix array of ai into bi. Okay, and this is for every like this is for prefix array, that is I'm going to first calculate ai into bi and find the prefix array of this one, that is prefix sum of this ai into bi starting from 0 to n minus 1, and this ai into bi starting from n minus 1 to the 0, and it should be like suffix sum of this value. Okay, so if I'm at this one, it should be like if I'm just calculating ai into bi, my ai into bi would be like 2 9, this is and this is 4, and this is 5, and this is 6. My prefix array would be like 2 11 15, and this 20, and it goes like 26, and this is from 0 to n minus 1, and suffix 1 would be like n minus 1 to 0. Okay, I'm not going to just explain in detail, also you can do that easily, and let's try to just find it out. What is my third one? Third subpart would be like if we try to just reverse this that is if we try to just reverse this subarray I to j, I am going to just maintain a 2D matrix. It should be like dp of n into n, that is n into n 2D matrix, a dp of ij. Okay, so I'm just going to write I and j. If I'm trying to just reverse this subarray from starting from I to j, what should be my value? Okay, that is value for reversing this subarray starting from this I to j. That is, if we try to reverse this subarray from this position to this position, what is my value for reversing. That is, you can easily see at the beginning my value is like 3 into 3, that is I'm talking about this subarray only, plus 2 into 2. But after reversing this subarray, my value would be like 3 into 2. You can easily see if I'm going to just swap these values 3 and 2 and plus, just to write it down clearly, I think after swapping it will become 2 3, so 2 into 3 plus 3 into 2, just this one. That is, if we have been said what is the value of dp of let us say we have 0 based indexing 0 1 2, what is the value of dp of 1 2, you can easily see my value of dp of 1 2 is this one, that is value obtained after reversing this subarray. Okay, so this first subpart you can easily do that, second subpart is the you can also easily do that, and third subpart is going to be quite tricky. Let's try to talk about that, how we are going to do that for the third subpart. Okay, so I'm just erasing this one and let us try to first focus on how we are going to do that. Okay, so you can easily see if I have only single element, that is the dp of I into I. If I have only this single element, what is the value that that is going to be like the if single element is like reversed, you can easily see if single is element is going to be reversed, my value would be like again ai into bi. It doesn't affect the value that I am going to say. Okay, so if my only if I'm talking about this only subarray, my initial value is already 3 into 3 and final value will also be 3 into 3. Okay, so let's talk about the length equal to 2. That is, I am talking about in the previous case, that is only a single length subarray. That is length of subarray is 1. Let's talk about two length of subarray. Now this is going to be quite tricky. If I am talking about two length subarray, let's say that I am at position A2 and A3 and I am also at this position B2 and B3. Okay, so if I am at this position and I am just trying to, okay, let's just find out what is my initial sum. My initial sum would be like A2 into B2 plus like A3 into B3. Okay, so what is my final sum after just reversing this subarray? My final sum after reversing this subarray is like, you can easily see, let's try to first write down what is the subarray that is after reversed, that is we obtain after reversing this one. Okay, it should be like A3 and A2. My sum would be like sum of these two product and sum of these two product. Okay, it should be like A3 into B2 plus and okay, so A2 into B3. So this is my sum. You can easily see, just have product that has summed up the product of the cross ones, that is this one and this one. Okay, my sum would be like this one. Okay, so this is going to give us a brief idea that we can easily build this dp matrix that I've already built over here. Okay, so for just length equal to 2, what you are going to do, that is for length equal to 2, just you are going to perform these two things. Okay, and you are going to do like dp of I into I plus 1 would be like a product of this ai into bi plus 1, that is the cross one for this bi matrix, plus this is ai plus bi into ai plus 1. Okay, and let's say what about this length equal to 3. Okay, now you, if you are just focusing on only length equal to 3, you can also just easily answer about that, how you are going to just easily answer. Let's try to also understand that also. Okay, I'm just okay, so let me just erase this one clearly. Okay, yes, this is done. Okay, if you are just focusing on this 3 length, you can easily see what if we try to reverse this for length equal to 3, we have already known that value that we need to do for this length equal to 1. That is, if we try to reverse this 3 to 1, it would become like 1 and again 2 and again 3. You can easily see the value that needs to be mattered is only the ending ones 1 and 3, and the value that in between we have already found that value. How we have already found that value? You can easily see my current length is 3, and if we subtract these two ending values, my length would become minus 2, it would become 1, and we have already found that for one value. Okay, That is, I am just trying to find out starting from length equal to 2, then it goes up to length equal to 3 subarray, length equal to 4 subarray, and so on. Okay, and if we try to find out for length equal to 3, we have already found out the values for length equal to 1, length equal to 2, and so on. Okay, let's try to find out for length equal to 5. If we try to find out for length equal to 5, it means that we have already found the values for length equal to 3, 4, and 2 also, and starting from 1 to this 4. Okay, so my array values will be like a1, a2, a3, a4, and 5. Let's say this is the subarray of length 5, and if we try to reverse that, it will become like a5, a4, a3, a2, and a1. Okay, so this is my subarray, and correspondingly we have the values of b like b1, b2, b3, b4, b5, and you can easily see this is the length 3 subarray, and we have already found this subarray because I am talking about length equal to 5. So I have just pre-calculated the length equal to 3 values, and for length equal to 3 I have also already pre-calculated the length equal to 1 values for that is subarray with length equal to 1. Okay, using these two base cases for 1 and 2. Okay, so if I'm talking about this one, the main thing that you should think that we have already found this subarray of length equal to 3, and what needs to be mattered is the ending ones a5 and a1, and you can easily see these values are going to be only swapped. So what I need to do is for every value of dp of ij for length equal to 5, I can just easily answer that. I'm just going to write it down the one dp relation. Okay, so let me erase this one, and I'm going to just write down one dp relation that is for dp of ij. So that is for a particular length must be equal to dp of I plus 1 and dp of j minus 1. That is, we are just removing the extreme ones, and we have already found this value plus. And what happens if you swap these operations? You can, if I have just swapped these values, like you can see previously we have a1 at this position, now we have a5 at this position. I'm going to write a of I into b of j. Just I've just swapped this ending ones plus b of I into a of j. Okay, so this is the way I'm going to just fill up the dp matrix, and finally you would obtain like this one. And we can easily answer for every subarray. That is for I, that is we have a subarray starting from I and ending up to j. We can just easily answer what is the value at after reversing this subarray. You can easily see the value after reversing this subarray would be like this dp of ij plus prefix of I minus 1 plus suffix of I plus 1. That is the values that I have already pre-calculated, the prefix values ai into bi and the suffix values ai into bi, starting from I plus 1 to the end one, and for prefix starting from 0 to I minus 1. Okay, so this is the method I am going to use. If you are not going to understand this one till now, no need to worry about. I am going to explain the entire thing in the coding section also. Okay. Okay, here is the code that you are going to see. You can see accepted code. Okay, so you can easily say I have taken the array A and taken the array B from 0 to n, 0 based indexing I am going to use, and here is a prefix and suffix array for ai into bi values, prefix sum and suffix sum. Prefix of I like ai into bi, and if I is positive, just sum up all the values prefix ones, and similarly I have just generated the suffix ones also. Okay, and my answer would be initialize with pref of n minus 1. What happens if you are not going to reverse at most sub one subarray? That is, if I am not just reversing any of the subarrays, my answer would be like only this one. Okay, and let's try to generate this dp matrix. Okay, which is going to like a dp of ij will tell us that what is the cost for reversing this subarray, what is the value that I am going to get for reversing this subarray starting from I and ending up to j. Okay, so you can easily see this dp of I into I just would be like ai into bi, just reversing one subarray would be like same as previous ones, that is reverse, just reverse that subarray of length 1 or just don't reverse that subarray of length 1, it doesn't matter. So my this dp of I and I would be initialized with ai into bi. It means that I am just going to reverse the subarray starting from I and ending up to this I also. Okay, and you can see I'm just talking about my length equal to 2. Okay, so dp of I and I plus 1 would be like ai into bi plus 1 and ai plus 1 into bi. I'm just if for explaining purposes I have just generated for this length equal to 2 separately. You can also just do that in this one also, starting from length equal to 2. Okay, so just for explaining purpose I have done this one separately. That is for length equal to 2, dp of I is to subarray starting from my current I and ending up to I plus 1 would be like that is if I am just reversing this subarray, what is my new value? New value would be like ai into bi plus 1 and ai plus 1 into bi. And let's talk about length equal to 3, and it goes up to length less than equal to n. That is for every I and ending up to subarray at j, my dp of ij would be like if you want to reverse the subarray starting from I and ending up to j would be like dp of I plus 1 and j minus 1. That is, we have already found the subarray of length L minus 2, and what matters is like just swapping the extreme values. Okay, so if you swap the extreme values, it would be like ai into bj plus aj into bi only. Okay, so this is the term that is going to differ if we try to calculate the subarray for length L. Okay, and what is my answer actually? So my answer would be like just traverse and check for all the subarrays, and what would be my new value for reversing that subarray starting from I and ending up to z. Okay, so I'm just trying to find out the different subarrays. That is, is going to start with 0 and ending up to n minus 1, and j is going to start from I plus 1 and ending up to n. And my answer would be like just reverse this subarray would be like dp of ij. And if I'm talking about this I and j subarray, that is, let's say I'm talking about this one, so you can see the index I plus 1 up to this n, and for this prefix 1 should be like as of previous value. So if I is going to be like positive, my current answer would be incremented by prefix of I minus 1, that is ai into bi value starting from I equal to 0 and ending up to I minus 1. And similarly for this j, that is suffix of this starting from this j plus 1. Since my subarray I am talking about is starting from I and ending up to j. Okay, so I need to do these three things. Okay, I'm just check the corner cases also, that is I should be positive and j plus 1 should be less than n. My answer I'm going to take should be like maximum of all the subarrays, that is subarray that I'm going to reverse starting from I and ending up to j. Okay, so this is the basic approach, dynamic programming approach, that I have used to solve this problem efficiently. Okay, so if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.